This chart is on the top of page 2 of your notes. So if we start with any given element, so this one is selenium Se, that's number 34 on our periodic tables, which means we would have 34 protons, and as an atom, it would also have 34 electrons. Let's say 34 protons. The number of valence electrons that it has is something that you can either count from its electron configuration or draw its Bohr model, or now that we know the little shortcut, we can just look at our periodic table and say, I labeled it as 6 valence electrons, so I can put 6 valence electrons here. The Lewis dot structure is only depicting those 6 electrons, so instead of doing all of the electrons like in a Bohr model, we're going to just draw the symbol, Se. Make sure that when you do this, you copy the symbol exactly like it is on the periodic table, meaning the first letter is always capital, and if there is a second letter, it needs to be lowercase. So Se, and we're going to put all 6 of these valence electrons around it one at a time until all of them are one at a time, and then only pair them once each side has one. So what that looks like is 1 electron, 2, 3, 4, 5, 6. It looks like there might be a dot there. I think that's just from bleeding through on the other side. But what you should be able to tell is that 2 electrons are unpaired in the valence shell of selenium. If we have 6 valence electrons, it wants to do what? Gain or lose how many electrons? Gain 2 so that it has 8. So it wants to gain 2 electrons. But when it gains 2 electrons, it ends up with a negative charge. Because if I have 34 protons and I did have 34 electrons, gaining 2 means I now have 36. So my overall charge is negative. So my ion formed is going to be Se with a -2 charge. And the noble gas that this is trying to look like, so if I have 34 protons normally, and I had 34 plus 2 electrons equals 36 electrons now. The element that has 36 electrons is krypton. So that is the noble gas that it's trying to look like. I'll do the next one with you and then give you some time to work on the rest of the chart on your own. So if I look at barium, barium is number 56 on our periodic table, which means that it has 56 protons, and normally it would have 56 electrons as well. So as an atom, 56 protons and 56 electrons. The number of valence electrons, since barium is right here in group 2, is 2 valence electrons. The Lewis dot structure would be Ba, and I'm going to put those 2 electrons on it. It doesn't matter where the 2 go as long as they're on 2 different sides. So you can do side and side, top and bottom, side and top, whatever. I generally just try to space them out a lot. If you only have 2 valence electrons, what are we trying to do? Gain or lose how many? Lose 2 electrons. Perfect. And then my ion that's formed is going to be Ba. If you lose 2 electrons, so now instead of 56, I actually have how many? 54. So if you lose 2 electrons, I have 54 electrons, but I still have 56 protons. It's going to end up being a +2 charge. And then that 54 should be the atomic number of the noble gas that it's trying to look like. So if I look this up.
The rest of B8, I couldn't see it.
Oh, I'll go back. 54 is xenon Xe. So I'll put this there. And then I'm going to pause the video here so that you can take some time and practice the rest on your own. All right, so something I wanted to point out that as I'm walking around watching you guys It is confusing that when you gain electrons, you end up with a negative charge. So students are really kind of mixing this up. Keep in mind that what you're gaining is something negative. So if you gain electrons, I'm going to put this note up here. So if you gain electrons, you're going to have a negative charge. We call that an anion. And if you lose electrons, you're losing something negative, that's like a double negative, you end up positive. And that is a cation. And then I'm going to go ahead and also put this on the back. So on our periodic tables where you did this, I would maybe make a note for yourself, especially because I will definitely have you using periodic tables on your test. Probably not this one since it's attached to your notes, but when you get a new periodic table to take your notes on, put this on there so that you don't get confused. Positive charge is called a cation. And it got that way by losing electrons. And then a negative charge is called an anion, and it got that way by gaining electrons. Alright, if we are back on page 2, aluminum is atomic number 13. So that means it has 13 protons and normally 13 electrons. The number of valence electrons according to my periodic table is 3. So its Lewis dot structure would look like this with 1, 2, 3 electrons on different sides of it. In order to become stable, it wants to lose all 3 of those electrons. Its symbol, when it loses 3, it's going to have a positive ion. So it's going to be Al with a plus 3 charge. If I lose 3 electrons and I started with 13, 13 minus 3 gives me 10 electrons. Which noble gas has 10 electrons? I think I heard it. Neon. Perfect. The next one is Kr. That's krypton. You might have noticed something special about krypton. It is atomic number 36, which means it normally has 36 protons and 36 electrons. The number of valence electrons it has is 8, so its Lewis dot structure would look like this. If it has 8 valence electrons, it doesn't want to gain or lose anything, so neither. It's not going to form an ion, it's just going to be a plain atom, since it's not gaining or losing any atoms, or any electrons, I mean. And its noble gas that it wants to look like is just itself. It's perfectly happy, perfectly stable how it is. The next one is nitrogen, N. That is atomic number 7, according to our periodic tables and the column that it's in. Number 7 has 5 valence electrons. So its Lewis dot structure, we would have 1, 2, 3, 4, 5. I would want to do what to become stable? Gain 3. The ion that's formed, if we're gaining 3 electrons, it's going to have a negative charge. So it's going to be nitrogen with a negative 3. If number 7 gains 3 electrons, it has 10 electrons. Which noble gas is it trying to look like? Neon. And then the final one is lithium. Lithium is atomic number 3. It has 1 valence electron. Its symbol is Li with just a single electron. It wants to lose that 1 electron. It would become an Li with a plus 1 charge ion. And if I have 3 electrons and I lose 1, I have 2 electrons now. Which noble gas is that? Helium. Notice on this chart, when you are looking at the Lewis dot structures, most of you were able to draw these really well. The pattern that you should be picking up on is that if you have less than 4 valence electrons, you're going to lose your electrons because it's easier to move them. If you have more than 4 electrons, more than 4 valence electrons, you're going to gain until you become stable because it's easier to gain that number. It's when you have exactly 4 electrons that it can do either one, so that's kind of like our threshold of what it's going to do, gain or lose. Any questions on this part before I move on?
No, wait.